We will now focus on how to graph logarithmic functions by hand. So to do this, if you read the first sentence here, okay, it says to graph y equals log base a of x, we're going to use the fact that its inverse function is y equals a to the x. Okay, so to graph a simple basic logarithmic function by hand, we're going to rely on its inverse function, which is an exponential function. Okay, so here we go. We're just going to jump into this. Okay, in example 5, it says sketch the graph of each of the following functions, then list the characteristics of each graph. Okay, so if you scroll down, we have some functions to work with. We have log base 2 of x, that's the first function we're going to graph. And then in part B, we're going to graph log base 2 of x plus 3. And then in part C, at the top of the next page, we're going to try to graph log base 2 of x plus 3 minus 1. Okay, if you look at all of these, they all involve log base 2. Okay, so that's where we're going to start. Okay, in fact, part A is simply the function log base 2 of x. Okay, so that's where we're going to start. Okay, parts B and C, those functions are just some kind of variation of log base 2 of x. So what we'll do is we'll consider that log base 2 of x, the function in part A, it's going to be our parent function. And then we just have to apply one or more transformations to get the graphs in parts B and C. Okay, so that's how we're going to approach this problem. Okay, all right, let's turn to part A. We're going to focus on graphing log base 2 of x. Okay, so we are going to write down its inverse function. Okay, the inverse of this function, since this is a base 2 logarithm, its inverse function is the exponential function of the same base. Okay, so 2 to the x is going to be its inverse function. Okay, we know how to graph 2 to the x. We've done that before. Okay, so let's refresh our memory on the exponential function. Okay, so I'm going to make a table of values over here. Okay, we are always in charge of x. Okay, I'm going to pick a few things. So I'm going to pick 0, I'm going to pick 1, I'm going to pick 2, and let's see, I'll go ahead and pick 3. Okay, and then I'll pick -1. Okay, so that should be enough. Like I said, we did this in an earlier section. Okay, I'm going to graph the exponential function first. Remember, that's not the end goal. We're trying to graph the logarithm, but we're going to use the inverse function to get there. Okay. All right, so we need to take each of these x values, plug into the exponential to get a y value. So I'll start with the 0 as our x value. If we plug in x equals 0, we're going to get y equals 2 to the 0. Anything to the 0 power is 1, so that's going to be the point 0, 1. Okay, and then I'll plug in 1. Okay, so that's going to give me 2 to the first power. Okay, that's going to give me 2. So we'll plot 1, 2. Then I'll plug in 2 for x. I'll get 2 squared. That's 4. Okay, so the exponential function will go through the point 2, 4. And then I'll plug in 3. So I'll get 2 cubed. That's 2 times 2 times 2. That's 8. So our exponential goes through 3, 8. Okay, then I'll go and plug in the negative x values. So that'll be 2 to the -1 power. That's the same thing as 1 over 2. Okay, so we need to plot the point -1.5. Okay, this is the exponential function. Okay, all right, so let me go ahead. You don't have to plot this graph. Okay, I'm just going to put it on here for a visual. Okay, so the exponential goes through 0, 1. It goes through 1, 2. It goes through 2, 4. And then 3, 8. And then the other point will be -1.5. Okay, and it behaves like any exponential does. One side is going to climb quickly. Okay, the other side is leveling off here at the x-axis. Okay, This is the graph of f inverse, which is 2 to the x. This is not a logarithmic function, okay? We're about to do that, okay? So we learned a while back how to deal with an inverse function, okay? To form the inverse function, all you have to do is switch x and y, okay? So what I'm going to do here is I'm going to make another little column here, okay? And I'm going to write down the points on the graph of log base 2 of x. All I have to do is take the points, the coordinates on 2 to the x, and switch the x and y points, okay? So, -1, 0.5, switch x and y. 0.5, -1 is going to be a point on the graph of log base 2 of x. And then take 0, 1, switch x and y to get 1, 0. 1, 2, switch the points, okay? You're going to get 2, 1. 2, 4 is going to go to 4, 2. Lastly, 3, 8 is going to go to 8, 3. Okay, these blue points, these ordered pairs, these are points on the graph of log base 2 of x. Okay, so let's plot them out and see what it looks like. Okay, so we've got 1, 0, we've got 2, 1, we've got 4, 2, and then we've got 8, 3, and then we've got 0.5 as your x value, -1 is the y value. Okay, so if you connect the dots, you're going to see what a logarithmic function looks like. It's kind of doing the opposite of what an exponential function does, okay? One side grows very slowly, okay? So we're climbing there, but it's very slow. The other side is leveling off, not horizontally. An exponential function levels off horizontally. This thing is leveling off vertically. Okay, so it's getting closer and closer to the y-axis without ever touching it or crossing it. Okay, so this blue graph is the function f of x is equal to log base 2 of x. Okay, that's all you have to do to graph a logarithm, a basic logarithmic function. Okay, so like I said, what we just did, we were trying to graph log base 2 of x. So what we did was we started with the inverse function, which is the exponential function of the same base. Once you have points on that graph, you just switch x and y to get points on your logarithmic graph. If you instead were trying to graph log base 3 of x, you would start with the inverse function 3 to the x. Okay, make a table of values, plot points on 3 to the x, and then switch the x and y's to get points on the graph of log base 3. Okay, same thing if you were trying to do log base 4. Guess what you're going to start with? That's right, 4 to the x. Okay, you start with the inverse function, make a table of values, plot those points, and then just switch x and y to get points on the graph of the logarithmic function. Okay, all right, so let's go down here. Okay, underneath the graph, we're going to list out some of the characteristics of the blue graph, which is log base 2 of x. I'm going to go ahead and box this in blue so you know which graph is which. All right, let's look at the domain. Okay, so the domain of the blue graph. Okay, so you're going to find your leftmost point. Okay, the leftmost point on the graph is essentially the y-axis. Okay, the blue graph never crosses or touches it. It actually has a vertical asymptote. The y-axis is a vertical asymptote for this graph. Okay, so essentially the leftmost x value on this graph is x equals 0, but we never cross or touch it. So we're going to write down 0, but we're not going to include it. Okay, as soon as you cross over x equals 0, your graph starts. Okay, you can have an x value of like 0.000001. Okay, all right, your rightmost point on the graph. Well, the graph keeps going and going and going this way. If you follow my highlighter, it keeps going this way forever. Okay, so the biggest the biggest x value is going to be positive infinity. Okay, so your domain is going to be all positive numbers. Okay, x can be any positive number. Okay, all right, what about the range? Well, range, you're going to write down your y values. You're going to go from the bottom to the top. Okay, the graph keeps going down, 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 down forever. So the lowest y value is going to be negative infinity. Okay, the graph is climbing very, very slowly. Okay, it is rising, but very slowly. It may take a billion years, but it's eventually going to go up to positive infinity. Okay, so the range is all real numbers. Okay, the domain of an exponential is all real numbers, always. The range of a logarithm is always all real numbers. Okay. All right, what's the x-intercept of this particular graph? Well, you can read it right off of the graph. It crosses the x-axis at the point 1, 0. So I'm going to write x equals 1, or you can write it as an ordered pair, 1, 0. Okay. Lastly, we need the vertical asymptote. Remember, exponential functions have horizontal asymptotes. The logarithms are going to have vertical asymptotes. They're kind of opposites of each other. Okay. We already said that the vertical asymptote here is the y-axis, but you need to write it as an equation. Okay, the equation of the y-axis is x equals 0. Okay, because any point that you pick on the on the y-axis is going to have an x value of 0. Okay, so these are the characteristics of the blue graph, which is f of x is equal to log base 2 of x. Now we're going to move on to parts B and C. Okay, they are both going to involve some variation of log base 2. So we're going to have to bring back the transformation rules. Let's take a look.